everything is map work. So unfortunately, for all your assessments, you will be given one map and you're going to work through that one map throughout your assessment. I know one student was not happy with this, but this is the assessment criteria for this module. So we're gonna work with a couple of maps which will prepare you and give you confidence that whichever map you are given, you are able to work through it. The most important thing is for you to understand the basic concepts on how to apply them. Then any map that you are given, you will ace it. I can even give you a map of 1964. As long as you know the basics, you will be able to sail through and answer all questions because the basics don't change. So this is an old map. So basically what students were given then, they were told to refer to map A, which has elevations in meters above sea level. There was some drilling that happened, borehole drilling at point A, B, and C, which we will see. And they were given some geological information, which they had to break down and analyze for them to actually outcrop. So with this content, when you analyze your data, the first thing you want to do is draw strike lines, because strike lines are key to everything you do. They are key for you in outcropping the full map area on your page, and they are key when you're answering questions in terms of your calculations. So if you do strike lines wrong, then your whole map will be wrong. That's the sad part. So in this case, they had a bottom contact of limestone that was intersected by vertical drilling at 60 meters at A, 60 meters at B, then 30 meters at C. The limestone had a vertical thickness of 90 meters, and then it is overlain by sandstone, which is a vertical thickness of 60, and the sandstone is overlain by shale, which is a stratigraphic thickness of 19.68 meters. So that was what background they were given. So if you were to take this information, if we were to compare with the last assessment you did, you were given a complete map. So in this case, it's a different one. You are given a blank map. You have to break down the information that you were given before, and from it, you must then produce a geological map. So for this class, I'm just taking you back to basics, teaching you how to produce your own map. And if we have time, we can look at a few calculations from this own map. You're welcome to stop me at any time. So if we were to look at this map, all of your maps will have contour lines, they will have a north arrow, and they will have a scale, right? And you'll be given some geological information if you are to produce a map. But if you are given a map that's already complete, you must analyze and take time to understand what is overlaying, which is underlaying, where's the strata deeping, where's the deep direction, where's the true deep, and so forth, before you start your calculations. So from here, we know that based on this, there was drilling at ABC. There were some borehole interceptions at point A, B, and C. At point A, it was 60. At point B, it was 60. And then at point C, it was 30. And then when you were doing the basics, you were told that you can draw strike lines from information where there are 2 points on the same elevation. If not, you would be given a borehole problem. In this case, you are given a borehole problem. So if we look at our borehole problem, we would see that at point A, the surface elevation is 450, but there was nothing they found on surface. They found something 60 meters down, so we subtracted 60 from this 450. That's how we got the 390. Then at point B, it's 390. So from here, they had to subtract 60 again, which gives you about 330, which would now be the elevation for limestone. And then at point C, which is 450, subtracting 30, you would end up with 420, all right? But if you had not been given any borehole information, From this map, if I were to ask you to draw straight lines, I would have used point A, B, and C, giving you maybe a hint to work with from point A, B, and C. If you look at point A, B, and C, you'd see that point A is sitting at 450 and C is sitting at 450. So your first straight line would have been through AC if there was no borehole information. However, in this case, we can't start there because the information you are given is that from point, there were borehole interceptions at point A, B, and C. So we need to first subtract the borehole information that you are given so that we know for this lower limestone, where is the limestone sitting from point A? As much as point A is 450 on surface, there was no limestone. Limestone, they only found it 60 meters down, which means the true elevation is 390 for limestone if I'm standing from point A. From point B, it's the same thing, 60 meters down, so I would get 330. From point C, it would be minusing 30, it giving me 420. So from these 3 points, I then am able to draw straight lines. I must use this information for me to draw straight lines. Are you clear? A point of reaction or people speaking would be fine for me. So now, if I look at A, B, and C, none of these points are sitting on the same elevation. So I'm unable to draw a straight line. What do? I then have to interpolate missing values. How do I go about that? I then have to look at the lowest value and the highest value from this map, from these 3 points. My lowest value would have been a 330. My highest value would have been a 420. If I'm moving from 330 to get me to 420, along the way, I'm going to get a 390. Then which sequence am I going to follow for me to move from 330 right up to 420? You use the contour interval on the map. Contour interval, where do I get it? I get it from my contour lines. It will be a constant value throughout your map. If you look at your contour lines, you've got a 360, 390, 420, 450, 480, and so forth. You just need the difference. If 360 and 390, difference is 30. If you take 510 and 480, the difference is 30. If you take 450 and 420, the difference is 30. So you, on this map, we're going to be moving at a sequence of 30 because our contour interval is 30. So from point B, from this 330, I need to move at a sequence of 30 for me to get to point 420. So how many points am I going to move? From 330 to 360, I will be moving 1 point. From 360 to 390, it will be another point. Then from 390 to 420, it will be my last point. How do I then do it? You take a piece of ruler, you put it along your lowest and highest value. So from 330, we are going to 320 using a sequence of 30. Then you measure the distance with your ruler. Let's say you're getting about how many centimeters? Let's say you're getting about 9 centimeters, right? Then from that 9, you then say, how many points do I need to move? You need to move 1 point to 360, a second point to 390, a third point to 420, so that you need to move about 3 spaces for you to move from B to C. So that 9 centimeter that you got on your ruler, I'm just making an example using 9 centimeters. You will divide it by 3 because you need to move 3 spaces. Then the first part, you will equate it to 360. The second part, you will equate it to 390. The third part, it will be your 420. And from that, you will then be able to have points from B to C at a sequence of 30 equivalent spacing. Then from there, you've got this 390 here, which you've interpolated together with that 390 that you have from point A. You join these first 2 points. This will give you your first straight line. Did people get it? I understand those that are here for recordings. I'll repeat again. Once, yes. I thought I saw a hand. Okay.
Oh, no, it was a mistake.
Okay. So from point B to C, if you've got borehole interception and you are unable to use the existing points to produce you a strike line, what do? You interpolate missing values. You look for the lowest value and the highest value. In this map, our lowest is 330. I'm just repeating. Our highest is 420. Then we need to determine the sequence we're going to move on this map. We use our contour interval, which will be a constant value when you subtract two contour lines. In this case, it is 30. Then from 330, how many spaces will you need to move? You need one space to move to 360. Second space would be 390. Then the third space would get you to 420. So you're moving 3 spaces. Then you take your piece of ruler from here to there. I'm giving an example of just 9 centimeters. I know I need to move 3 spaces. So I say 9 divided into 3. So maybe I'm getting 333. So the first 3 I'll equate it to 360. The second I'll equate it to 390. And the third will be my 420. Then this 390 and this 390 will give me my first strike line. And then this, you can do the same thing on the other side, where now for B and A, where you have 330 and 390. You take a ruler, you measure the distance, maybe you're getting about 5. Then you said, if I'm moving at a sequence of 30, which we already know from our contour line, you would say from 330, you need 360, you get to 390, so you're moving 2 spaces. So if maybe you had 5 centimeters divided by 2, because you moved 1 space, 1, 2 spaces, then that space you would equate it to 360, then you have a 390. Then this 360 and this 360 will give you the second strike line, because already the first strike line was from 390 and 390. Now that you have 2 strike lines on the map, you are able to draw the rest of the strike lines across your map page, because you only needed to figure out how to draw 2 strike lines when you don't have any points on the same elevation. So for you to do that, you measure your equispacing. Now you take a ruler and measure the distance between here and here. If, let's say, your equispacing becomes 2 centimeters, then from there to there is 2 centimeters. Then you must mark a point of 2 there, another one, 2, another one, 2, another 2. Use your ruler to draw the rest of the strike lines. In this case, it was 2.1. Then you must measure another 2.1 here and draw a line. Measure another 2.1, draw a line, 2.9, draw a line. Same thing at the bottom, draw 2.1, get a line, 2.1, get a line down. And all your strike lines must be straight, they must be parallel, and they must always be equispaced. Because you can see from here, they are both 2.1 centimeters, 2.1 centimeters, 2.1 centimeters. Now, with these few strike lines that I have on my map, I can be able to tell which strata is my, in which direction is my strata dipping. I can calculate the dip of my rock units, because I already have an equispacing and I can see the direction. If I look just at these few strike lines, and you must always label your strike lines as you work along, because it will get complicated if you've got too many rock units on one map. Like this one, it's a 420. This would be a 390 lower line. This would be a 360 lower line. This would be a 330 lower line. So the next one would be a 300. The next would be a 270, 240, and so forth. When I go, because as I go up in this direction, my strike lines are decreasing. So it means if I go down, my strike lines are increasing. So now to outcrop, once you have strike lines across your whole map page, what you need to do, you need to look at each strike line individually together with the contour lines. Where the strike line and the contour line of the same elevation meet, you will mark points, and then later you will join these points, and then they will give you your outcrop pattern. So let us start. You can start on any strike line. Like let's start with this 330. If we look at this 330 lower limestone, is there any 330 lower contact? From this 330 and lower limestone, is there any 330 contour line passing through this line here? If I look at my contour lines, my 330 contour line is here and my 330 strike line is here. So they're not meeting anywhere. So I make nothing. I make no points. Then I come to 360. This 360 strike line, is there any 360 contour line passing through here? If I look at 360 contour line, it's up here. There's nothing passing, so I do nothing. Then I come to the 390. The 390 strike line, I look for 390 contour line. I've got this 390 contour line. It's passing here. There's one green point. Passing here again, it's another green point. So it's only 2 points. Then I come to the 420 strike line. I do the same thing. 420 strike line. I've got a point of 420 contour line. I've got a point of 420 contour line. So I've got 2 points. Then I come to a 450. 450, I do the same thing. I've got a 450 contour line passing here and the 450 passing here on the same 450 strike line. Then on the 480, I've got 1 point here. Then only these green points I'm gonna join, and this will give me the pattern of my lower limestone on this particular map. So what you do, you will join this green and this green. You will join, go up. You will join, go up. Then you curve down because there's nothing here. And then you come down, and you exit the page. You don't jump a point where there is no strike line, giving you leeway to go. I will upload these slides under additional resources. So that's how you would have got your outcrop pattern of the limestone, the lower contact of the limestone. Then they told us that the limestone has a vertical thickness of 90 meters, right? Now we need to outcrop the upper contact of the limestone using the same principle that we use when we outcropped the lower contact of the limestone. So to outcrop the upper contact, we do the same thing. So all these strike lines that we had initially written, this one, what was it? It was our 480 lower line. This was our 450 lower line. This was our 390, our 360, our 390, our 360, our 330, and so forth. Now, all of these strike lines, one by one, you're gonna add 90 to it. Whatever the elevation was for lower contact like this one, this is 330 lower line. If I must add 90 because I am given a vertical thickness, I must add 90, which will then give me 420. This 420 will be upper contact. So this line alone, as much as it is a 330 lower line, it is also equal to a 420 upper line. One line, it having 2 values for the limestone, a lower and the upper contact value. In a map, if I give you one value and the vertical thickness, you will determine the other one based on the vertical thickness given or the one that you need to calculate, either or. So this 360 lower line, if you add 90, you get 450 upper line. Same strike line, you just relabeling it because you have more information. You are now wanting to outcrop the upper contact of limestone. So here you had 420, here you had 450, here you would get 480, there you get about 510 and so forth. As you go up, you will do the same thing. This was 420. As you go up, it will be 390, it will be 360, 330, 300, and so forth. Then same strike line. We're not drawing new strike lines. We're using the same strike lines. Same strike lines, just different values. Now, for all these strike lines, we're now going to do the same thing that we did here. We're going to say strike line, contour line, same elevation when we're marking points. The aim for this is to produce a geological map. So from here, if this one, this is a 270 upper limestone. So it's a 270 strike line, and I've got a 270 contour line. So I mark my first point. The second one, it's a 300 strike line. So I'm looking for a 300 contour line. I've got a point here. Here it is a 330 strike line, and I've got a 330 contour line here and here. So I've got 2 points. Same thing here for a 360. You got 2 points using the the contour line. Then here it would be for a 390. You've got your points. Then you've got a 420. 420, you've got about 3 points because you've got this contour line 420. You've got the same contour line, but it's curving. So you must mark all of them here and here. And you do the same for 50, 450, 490, 480, 510, and so forth. And then you will join these points and they will give you an outcrop pattern for limestone. So this is the background work that had to be done. You were given a map that's already complete. Now I am showing you how to produce your own geological map from the information that we were given. So now we are able to, if we are given any calculations regarding limestone, we are able to calculate, because the most important things that we needed the strike line values and the outcropping on the map. So now if they said that the limestone is overlain, meaning on top of the limestone, there's another rock unit. In this case, this rock unit, it is the sandstone. And this sandstone has a vertical thickness of 60 meters, right? So if we are to go on to the map, we're going to add 60 on all the upper contact of the limestone strike lines and not on the lower contact because it's overlain, meaning the boundary between sandstone or the boundary on the sandstone side from the limestone, it is the upper contact. So from all these ones, what we had here, we had about 420. So this 420 upper lime, if you add 60, it becomes 860, 880. On this one, where it was 450, if we add 60, it's giving 510. On this one, and all of them, you add 60, add 60. Why am I adding 60? I'm adding 60 because I am given a vertical thickness of 60. So on all the strike lines, I add 60, I add 60, I add 60. Then I use this red, which I just made sandstone to be red in terms even in my writing. And I'm going to use these values to outcrop. So same principle, same strike lines. So now here we have a 300 strike line for sandstone, and there is no 300 strike line, 300 strike line, but there is no 300 contour line, so we leave it blank. Then we have a 330 strike line, and we're looking for a 330 contour line. There's a point here, so mark 1 point. The next one is a 360 strike line, so looking for a 360 contour line. Got a point there, you've got a point there. Then a 390, you got a point here, and you got a point here. For a 420, you had a point there, you had a point here. For 450, you had a point here and a point there. Then a 480, you had a point here and a point there. Then a 510, so forth. Then we join these points. You see? Then you join your points. You don't force them. And then at the end, what we have now produced, we were able to outcrop the lower contact of the limestone where we started. Then we were able to outcrop the upper contact of the limestone. Now we have outcropped the sandstone, the one in red. Now I can just throw you this map and give you calculations. Here, the purpose, it was just for you to learn how to outcrop. Any questions? I'll give it a minute for people to digest what I've said. Then from here, we are able to answer any questions that come with that was just to show you how to outcrop, which is something that you will be doing in your upcoming assessment. You will be given a blank map and you're going to be required to follow this process of outcropping. Then let's do some bit of calculations from that map. Ne? So I'm going to share again. So now what we have just done was just question 1, where we're just outcropping the limestone, the sandstone, and then we also need to outcrop the shale. Shale, they had given us a stratigraphic thickness, so we need to go backwards and calculate the vertical thickness. This is where we started. You still remember? And then we were able to produce the lower contact of the limestone. We were able to outcrop the upper contact of the limestone. We were able to outcrop the shale in red, and then the sandstone in red. And then the shale is in yellow. Basically, when they calculated the shale, the vertical thickness turned out to be 30 meters. So if we're going to work with 30 meters, I'll show you how to calculate backwards. For this shale, for us to be able to outcrop, what was 450 sandstone, because it's sitting on top, you add 30, you're getting a 480. What was 420 plus 30, you're getting a 450. So now you're using the yellow values to do the same thing and calculate, right? Now, if we were to calculate the depth of the bed, I'm just making an X. I think it's one of the questions that they ask. And then they said determine the horizontal thickness for limestone, shale, and conglomerate combined. So from that map that we have, we were given the vertical thickness of limestone being 90. We were given the sandstone being 60. We were given shale to be 30 because we calculated backwards. Then you would add the total, because what the question had said, they want to determine the horizontal thickness of the limestone, sandstone, and shale combined. So all your answers must be combined and not individually. So for lime, we have 90. For sandstone, we have 60. For shale, we have 30. So combine them, we have 180. Then for us to calculate the depth, for us to do the horizontal thickness, to get this depth of 49, what we do, we take any two strike lines, be it strike line values for shale or strike line values for sandstone or strike line values for limestone, you will still get the same depth throughout. You can calculate individually, you will get the same answer. So let's say like from here where we started, this 330 and this 362 strike lines. What is the vertical? Because for us to calculate the depth, it's VT over HT. So V, in this case, the VT would be the, if we're measuring it, we're calculating it from the two strike lines where you've got 330 and 360. So the difference is 30, right? If you may be looking at the sandstone value is here, it is 390 and then 420. So the difference between the two is 30. If you're looking at the shale, I just wanted to show you that either whichever strike line values you use, you'll get the same answer. If you're looking at the 360 and the 360 and the 390, the difference is 30. So VT is equal to 30 over HT is this equispacing, this 1.2 in centimeters. Then you have to convert it with this given scale and get it into meters. Then you use your calculator and you get a straightforward value, which they had 49. Then you plug in your equations for us to calculate the horizontal thickness. We use this equation where ST is equal to HT times sine theta, but you must make HT the subject of the formula. So for you to get here first, you must first calculate the stratigraphic thickness combined. So we were able to do the vertical thickness combined for all the rock units. We know our dip is a constant value and it's the same whichever rock units we're using. And then you calculated the stratigraphic thickness combined. Then from there, you make HT the subject of the formula, and then you are able to get your answers in meters. That is just how to calculate the horizontal thickness. Another way to get it, because they had said from the horizontal thickness from limestone to shale, you can either calculate it or you can measure. For you, this is the calculated method. To measure, what you do, you take your original map that you produced and look, because they are working from limestone, the base, the lower contact of limestone till the top of shale. So what you will do, you will look for any lower limestone value, lower contact. So if in this case you're working with this 330 lower limestone, you must go look for a 330 a shale value, because your vertical your horizontal thickness, they want it from lime to shale combined. So everything inside must be included. So what you do, if you are going to measure it on your map, you're gonna look, in this case, you're just gonna use 330 lower lime, then you must go look for a 330 shale. The reason we are not using 330 upper lime is because if we use 330 upper lime, we are excluding the limestone contact. We are just working from sandstone, which would have been wrong. They had said they want a horizontal thickness from your limestone. So from the base of limestone till the top of shale. So if you are going to measure it from the map, use one strike line of lower contact and go look for the same strike line value of upper contact of the last rock unit. So in this case, lower contact limestone, we use 330, upper, then we look for 330 shale. You measure the distance with your ruler. In this case, they got 12.5 centimeters. You convert it with your scale because your answer is in centimeters, and then you got 156, which gives you the same answer you had calculated. So you either have an option for horizontal thickness to measure it off the map or to calculate it. But then I think most of you will mostly like be calculating if you are writing a major test, because you will not be able to be printing your map and calculating it on your own. But with us upcoming assessment, you decide which will work for you, whether to calculate or to measure it, because you will have a map given for you. And now from just this map, I want you to just do some other calculations. Like in the instance where if I were to ask you at point D, what will be the borehole? Okay, no, let's not use point B, D. Let's use point B. Just a second. At point B, if I were to ask you what will be the borehole interception for what was this one? For shale from point B. If you look at point B, remember now I'm trying to ask you a borehole interception problem. I'm just throwing it in. It was not asked. I'm just throwing it in for practice purposes. At point B, I would say for us to calculate borehole interception, we say borehole minus strike line. So our borehole, our contour line, my bad, contour line minus strike line. So the contour line here is 390. This 330 is what we extracted when we're doing borehole interception. So the actual elevation of point B on surface is 390. So we'd say 390 if I'm wanting to do borehole interception for shale, 390 for surface for contour line, and then for the strike line, I would read the strike line value. So in this case, it will be this one, the orange 510, because I had said for shale. So it will be 390 minus 510. So it's a negative answer. You would not intersect. I'm just trying to think of the questions you guys had struggled with before. And then another one had a problem with calculating thickness. To calculate thickness, what you just need to read strike lines. As you are building up your map, as you are outcropping your map, you will have different rock units. It is best to use different colors so that if I'm asking you any questions that's relating to limestone, I'm going to be looking at the blue writing on the strike lines. I know that for me, that one was for my limestone. If I ask you anything on shale, I would be reading the red values. It's the same line, but then this line, it has values for limestone, lower and upper contact, for sandstone, lower and upper contact, for shale, lower and upper. In some cases, you would find that I will only write upper contact values. It does not mean lower contact values are not on the map. They are there on the map. You must calculate on your own at the back of your head. If here I have a lower contact like this limestone, this limestone of 390 upper limestone. So it's this contact here. It's much as it's upper limestone 390, it is also equal to sandstone lower. It is also equal to the lower contact of sandstone of 390 because it's this boundary here. The same, this 450 sandstone, it is also equal to, it is the upper contact for sandstone, but it also equal to a 450 lower contact for shale because it is this boundary here, this red one. So in your map, you must be able to read your map for you to first determine which was deposited first. You must be able to calculate whichever rock units, know the rocks that are there, and then you'll be able to answer any questions from here. So for today, I would like to stop here. So I will stop sharing. If there are any questions, I will take. The recordings will be available. I will also make sure to upload these two presentations under additional resources. Then you can work on it on your own time. And then in the next class, I think I will teach you how to outcrop a fault. And then we also do 1 or 2 examples so that whatever assessment you have, you are confident to work through it. Any questions? I'm done on my side. Are people, yes, you can ask. Let me know if you want me to continue recordings or should I stop recordings?
Okay, Veronica? No, it's fine. It's fine, ma'am. You can continue with the recording. I just wanted to find out because on the initial slide, it was said that a shale was 19 point something. Yes. A vertical thickness. And then now it's... No,
it was a stratigraphic thickness.
Yes. So with the stratigraphic thickness, we use the stratigraphic thickness for lime, which was 90, right? And then we used 60 for sandstone.
That's vertical thickness. The catch here was that for limestone, you were given a vertical thickness. So when you have a vertical thickness, you don't draw new strike lines. You just straightforward change values on the same strike lines. And then for
maybe I didn't catch the question properly because I actually thought that it was all the vertical thickness.
No.
So that's the reason why I was actually confused because I was even calculating now that now the shale is 80 and it's no longer 19 point something.
If you are given a stratigraphic thickness of 19.68 meters, you must use that formula ST is equal to VT times cos theta. You have this 49 If you've got a calculator with you, you can plug it in. You've
Oh, so
this
it
deep,
it was calculated using the given value so that we'll be able to
yes,
find it. Okay, no, I
yes,
get it, ma'am.
yes. Then you would have made VT the subject of the formula. That costs 49, and then you've got this 19.68. Make VT the subject of your formula, you would get 30. For outcropping purposes, we use the vertical thickness to outcrop on the map. But
Yeah,
for
because I think
calculations, you either be asked to calculate the stratigraphic thickness or calculate the vertical thickness, and they are not the same. So you must be careful what are you being asked. Even the horizontal thickness, like the one we just did not so long ago, some of you are just using the words interchangeably when in actual fact, they are not the same thing.
okay, thank you, ma'am. Now I see, because I actually didn't realize that it was stratigraphic thickness and not vertical. Just saw vertical and then I just listed them under the vertical. Or
Oh, yes. No, it's fine. No, remember, I just take
Thank
a
you.
past paper, a very old paper. Remember, because this was a paper for that class, there has to be some tricky questions on the paper that will wake up a student to either pass or fail. So,
Yeah, no,
so in this case, the tricky
it got
part,
me there.
the tricky part was that the shale was not given as vertical thickness. It was given as stratigraphic. So if you just took that 19.68 and maybe you rounded it off to 20, you would struggle to plot it on your map because your contour interval here is 30. And now you are
Yes.
going to be adding 20. So what are you going to do? You're going to draw new strike lines to fit in this 20. They will not find anything because everything here is in 30. But that was the trick for this exam, for this assessment. If I tell you, first of all, they were given a borehole interception. And one thing, the first thing you know about strike lines is that you either draw strike lines from points on the same elevation or you work through a borehole problem. So the first thing, point A and point C were sitting on the same contour line. They were sitting on the 450, 450. So if a student did not pay attention to the borehole information, they would have drawn the first line from AC and they would have failed the exam, 0. Because whatever you're going to produce is out. First. So that's where this module, it's a very nice module. You must not get too excited. You must always be paying attention to what you are doing. Then the second one, if you manage to use your borehole and produce your limestone, you would produce your sandstone, no problem. Then the problem was going to be shale, because limestone, you are given a vertical thickness, sandstone, you are given a vertical thickness, and shale, you are given a stratigraphic thickness. You must first calculate the dip and then convert back to vertical thickness, and then take that vertical thickness and come and plot. So in any assessment, this is, I can say it under recordings. From assessment 2 till assessment 6, you will be given a map every time, a new map that you have not worked on. And in all the map I will be giving you, there is a catch that you must first study your map, because there will be an easy section and there will be a difficult section. There'll be one little thing that I'm going to twist that will either make you pass or fail. I'm declaring it early, so don't say that I did not warn you. So every statement that you are given, read it carefully. Some will be easy to answer, some will be difficult to answer. At the end of the day, it's an assessment. I must test your understanding skill and your application. So that's just my disclaimer. I like your question. Some students would have picked up, they would have failed. If I were to give you the same map, then some would have failed because they wouldn't have picked up that. How come? So from the few comments we had earlier, it was thickness calculation, which I hope I have assisted you with, and it was borehole interception. And then we've just looked at how to actually produce your own map. And I can guarantee you, assessment 3, you are producing your own map. You're getting a blank map. It will be open for a whole week for you to do. You print it on your own, you work on your own, you calculate on your own, you upload on Friday, and then I will start marking on Monday. I think I will load it on the 13th and close it on the 7th, on the 20th. I think I'll double check when is the opening and closing date. But you'll have a whole week to do the assessment. And with this knowledge, I am rest assured, if you pay attention, you'll be able to do it. So from my side, I am done. I don't know if there are any more questions. I'm be happy to take questions. I'll stop the recordings for now.